Good day, I'm Professor Dr. Bankole Johnson, and welcome again to another episode of Time Travel in Medicine. On this episode, we're going to answer the question, I hope in part, on why we dream. Now, let me have a little bit of a spoiler. We don't exactly know why we dream, but we do have some important clues. In the field of neuroscience, there is a theory that we dream to be able to preserve the integrity of our visual cortex. Let me explain this to you. If you were born blind, you don't have vivid visual dreams. Your dreams may consist of touch or movements, but they're not like the type of dreams we get when we are sighted. Dreaming and sleep are consistent with one another. So because we live on this planet, we have about roughly 12 hours of darkness and about 12 hours of light. And in between, we can sleep in the dark periods for about 6 to 8 hours. Now, during that period, we can have two types of sleep. One is called rapid eye movement sleep, and the other one's called non-rapid eye movement sleep. In rapid eye movement sleep, we have these visual, vivid dreams. In non-REM sleep, we don't tend to have such vivid sleep, and we tend to remember the dreams mostly that are vivid and are powerful in our imaginations. So why is it that we dream? Our visual cortex is responsible for the perception and understanding of light perception. But at night, it's not activated. And because there's a phenomenon in the brain called neuroplasticity, whereby our brains continue to make new connections, other parts of the brain can begin to take over. So, in order for us to preserve our eyesight and our ability to see clearly, our brain mounts this defense by producing these electrical stimuli that stimulate our visual cortex. Fascinating, isn't it? Well, there are many reasons to think that this theory is not too far off. For example, in other senses in which you may have a limb severed, you can still develop some seeming sensations there. This phenomenon has actually also been studied in all sorts of animals, in fact, animals that are even nocturnal, and it seems to be that this theory holds true. But what do these dreams actually mean? One type of memory that we have is what is called declarative memory. That is something that has actually happened to us. This tends to happen in non-REM sleep. Imaginative memory tends to happen in a REM sleep. In REM sleep, we have all of these powerful activation of our cortex, visual cortex, to provide rapid eye movements, but the rest of our body is paralyzed, and it's probably a good thing that that happens, so we're not thrashing about in our sleep while we are dreaming these vivid dreams. It's thought that in REM sleep, we are basically honing and pruning our memories, we are improving our body's metabolism, we are processing information, particularly emotional information, and we're also making our memories of what we have learned during the day more compressed and more able to be accessed. Therefore, in REM sleep, two parts of the brain are very, very important. One is a part of the brain called the amygdala, which is meant to be used for the processing of all of this highly emotional information. And the other is the hippocampus, which stores our memories. But I'm going to say there's a third part of this that is also important, which is our frontal cortex. Now, this is responsible for our thinking and reasoning. But in order for us to dream fully, that also in some way has to be deactivated. Now, why do we remember our dreams vividly? Because our dreams encode fragments of memories and information. These fragments of information are pruned when we wake up, and therefore we start to put together various aspects of our dreams. Now, some of you may wonder why I haven't spoken about dream theory and what dreams really mean. The truth is, we don't really know. What we do know is that there are certain aspects of our emotional life that are triggered in our dreams. Stress, for example, is a heavy provocation for dreaming, and dreaming stressful dreams. Loss is also one of them, traumatic events. And in fact, a lot of dreams that most people have tend to be more negative than positive because those are the most powerfully reinforced memories in our brain. One of the fascinating things about neuroscience nowadays is that we've begun to try and understand some of the parcels of sleep and how they are related to emotional processing. One of these is the new understanding that theta waves in the brain, which are one of the slowest forms of brain waveforms, is associated with lucid dreaming. This occurs usually in the early part of sleep, but it can also occur during REM sleep. Now, what could we do to enhance, if you like, theta waves in the brain and improve quality of sleep, as this type of sleep is associated with deep relaxation? Over here, we have a theta chamber, and in the theta chamber, we provide binaural beats. These are beats in each ear of slightly different frequencies, and the brain tries to reconcile these different frequencies by producing a singular frequency or tone in its perception. This puts the brain into what's called theta, the most relaxing part of sleep. And when you're not sleeping, some people may also have a preponderance of theta waves. It's said that people who meditate deeply can have a lot of theta waves, and this theta waves is associated with basically reaching back into what is often called the subconscious mind, although we're always conscious, and being able to be creative or relate activities and put them in a time frame that is more acceptable and less stressful. This machine, the theta chamber, is not found in many places, and we are so pleased that we have one that we can show you in its operation. And it takes about 30 minutes, and a 30-minute cycle in a theta chamber is equivalent in terms of theta wave production to about 3 days of sleep. So this is really quite an interesting piece of machinery to be able to regulate sleep, decrease stress, promote lucid creative dreaming, and also a sense of deep relaxation. So in sum, dreaming is very important for the maintenance of our bodies, our metabolic state, the consolidation of memories, the ability to understand how our memories are related to one another. It is also important for the preservation, perhaps, of our visual cortex, such that it doesn't become invaded by other aspects of sensation. Finally, we don't really know exactly what the tenets are for us to be able to go in and manipulate our dreams. Some people say they can go back and dream again and have lucid dreams and be able to get into their dreams and manipulate them. This tends to occur in most individuals only about once in a year, and some individuals don't have them at all. So I leave you with this mystery. Dream on, and I will see you again in Time Travel in Medicine. Thank you so very much.
If you like this program, please don't forget to subscribe by clicking on the button below. It really does help for us to be able to bring you this great content. See you soon. Bye-bye.